So the next topic we are going to see is about evolution of operating system. What is meant by evolution? What is meant by evolution? Evolution means how operating system came into existence step by step. That means the history of how operating system was developed. Evolution of man, the most famous Charles Darwin theory. Have you heard of that? It says that human beings were evolved from monkeys, right? That's the theory of evolution of man. Similarly, how operating systems evolved. What was the first kind of operating systems? In the previous generations, what operating systems we had? Okay, that is meant by evolution. Evolution of operating system means we'll be studying the first computers and what were the earlier system or earlier versions of operating systems. So the first generation, you know that it was ENIAC. I've shown you this photograph courtesy to Wikipedia. First generation of operating systems, 1940s to 50s. The first electronic computer came in 1940 to replace the mechanical computer. It did not have any operating system. The first in some books is given as 0 or 0th generation. Okay. It did not have any operating system and was used to simply make very simple calculations using plug boards. So these types of computers were called as mainframe computers. We'll see what is mainframe. The first operating system that was ever used for the real work was by GMNAA IO, produced by General Motors Research Division of IBM 704. So the first operating system that came into existence was in 1956, and that was by IBM for a particular purpose. Is that clear? After mainframe, the second generation of operating systems came into existence, and the most important development was batch operating system. In mainframe, what happened was we had a continuous operation going on. It was like a single stretch, a big one. What we did was we thought that it would be more time efficient if you could divide this into batches. Okay. So this system was called as batch processing operating system. So this type of operating system accepts more than one at a time. And these jobs are batched or grouped together according to their requirements. This was done manually with the help of a computer operator. Whenever the computer becomes able, the batched jobs were sent to the processor for execution. And gradually the output is sent back to the user. So batch processing is allowing one user at one particular point of time. Okay, but it is done, more number of jobs can be done at the same time. Okay, it is a single user, we have more number of jobs that can be done. So what are multi-programming operating systems? In multi-programming operating systems, at one time you can operate multiple programs. Okay. So these are multi-programming operating systems. There will be multiple programs that is uploaded into the main memory at the same time, and we have an interrupts enabled that makes this more efficient when compared to the second generation of operating systems. So the main advantage of third generation is use of multiple programs. when one program for an input-output operation, what happens? The CPU will be idle. So, okay, it will be used by another program. Say one we are giving fund previously in the second generation. What was happening was we didn't have any. If there is a user has given some job for printing, only after the printing is over, the next user will be allowed to use the CPU. Although CPU is idle. Okay, understood all of you? But from third generation onwards, what happened was, if the CPU is idle, another program can utilize this time and make effective use of processing. So very important concept, what is meant by multi-programming and how multi-programming was done in the third generation of operating systems. That you have a series of jobs, you have a set of jobs that needs to be executed one by one. Okay, so we have fourth generation of operating systems. Fourth generation of operating system, we have fourth generation of operating systems, we have single user environments and multi-user environments. We have built up graphical user interfaces. GUI means graphical user interface. What is meant by GUI? The most important feature that came into existence in the fourth generation of operating systems, that is from 1980 onwards, is the use of graphical user interface, interaction with mouse clicks, and so on. Right? The examples of operating systems that came into existence were MS-DOS, Windows 95, Macintosh, etc. They all had a single user environment system. Time sharing and multitasking operations in the fourth generation. In single user, the advantages are faster switching between multiple jobs to make the processor, utilizing the entire time of processor, allows multiple users to share computer systems simultaneously. Users can interact with each job while it is running. Okay, these systems use a concept of virtual memory or effective utilization of memory space. Hence, in this OS, no jobs are discarded. Every job is being queued up according to the priority. Okay, each one is executed using virtual memory concept. It uses processor scheduling. Examples are CTSS, Unix, etc. Multiprocessor operating systems. What is meant by multiprocessor operating systems? So this is a very important development because we have parallel operations happening simultaneously. Okay. Systems, multiprocessor operating systems are also known as parallel OS or tightly coupled operating systems. Such operating systems, multiprocessor operating systems, are also known as parallel operating systems or tightly coupled operating systems, tightly coupled OS. Such operating systems have more than one processor. Such operating systems have more than one processor in close communication, more than one processor in close communication that sharing the computer bus, sharing the computer bus, the clock, and sometimes memory and peripheral devices. It executes multiple jobs at the same time and makes processing faster. Okay. Multiprocessor operating systems are also known as parallel operating systems, parallel OS, or tightly coupled OS. Right? Such operating systems have more than one processor in close communication that sharing the computer bus, the clock, and sometimes memory and peripheral devices can be made possible. Right? It executes multiple jobs at the same time and makes the processing faster. The advantages of multiprocessor, three advantages are there. One is that you have an increased throughput. That means you have more effective utilization of the time. Speed ratio is much faster. Economy of scale, increased reliability. Multiprocessor operating systems. Advantages. First point, multiprocessor operating systems. Advantages. First point, increased throughput. By increasing the number of processors, the system work. When you increase the number of processors, what happens? The work gets divided and more work is done in a lesser time. That is called as increased throughput. First advantage, increased throughput. Okay. Network and network and communication, and you have a system called as distributed systems that came into existence. Distributed computing is a field of computer science that studies distributed system defined as computer systems whose intercommunicating components are located on different network computers. In a distributed system, what we have, you have a computer system here, you have, suppose you have a virtual machine or something connected here. You can use the printer here, printer, scanner, or any other processor. See, nowadays we need high-end computing facilities, no? Today we are using Google Cloud, right? Yes or no? In cloud computing, what we are doing? We are getting connected to a computer which is much far away. And then we are utilizing the resources kept there. Is that okay? This is called as distributed computing. Advantages of distributed computing systems. We can use resources from multiple sources. The computation speed increases, reliability and communications. We can always believe that there will be one or the other system working when we have multiple options. Then it requires networking infrastructure, local area network or wide area networks. So we can have multiple networks connected to a single system. Is that clear? Next, we have real-time systems. Real-time systems are those that respond to events within the predictable and specific time constants. See, we have real-time RTOS. RTOS is very important for you because we use this RTOS in embedded systems and so many other areas. We have a real-time operation, and that operation requires an OS that facilitates all the resources within that. Is that clear? What is an embedded system? An embedded system is a small operating. So an embedded system means you have a microcontroller, you have an operating system in that, and this program works with respect to particular devices. Say suppose you can embed a system into a washing machine. You can see the display now, washing machine, air conditioners, and so on. Okay, this kind of systems require real-time operating systems. So we'll conclude today's session with a small summary of how operating systems were evolved. Okay, in the initial first session, first we had mainframes. There were no softwares. There was no a particular operating system to control all the events. From there, we got coming into mini computers, and the most important development was batch processing in the second generation. Okay, that means the jobs were divided into different batches. Then we had multi-user systems. Then we have networking. Then we had Unix. So in 1970s we had multi-user systems. We had it networked with, and then Unix came into existence. Unix came into existence in 1980s. Okay. Then we had Microsoft MS-DOS. MS-DOS is different from disk operating system DOS. Okay. Then came Windows 95, Windows XP, Windows 10, and cloud operating systems. Okay. Is that clear? So if you have any doubts, you can ask me.